Okay, welcome everyone to Mission Control 1 of Orbital's 2025. And today we'll be spending about 2 hours on this fundamental topic on web development, which is quite a core concept if you want to develop a web page project. So before we dive into the content, let me just introduce myself. My name is ZhengHao and I'm a year one going year two CS student. And I am also a core team member of NUS Hackers. And because previously I have some experience in front-end development using React, so I'll be very happy to share with you what React actually entails, and hopefully you can bring back some practical skills by the end of this workshop. Uh, Next, I'll introduce you to my partner. They will also be also co-conducting this workshop. Homer, do you want to turn on your mic and say hi?
Hello everyone. So my name is Oman. I'm also a U1 CS, currently member of NDS Hackers, and I have quite a bit experiences in web development through project internships, and I can't wait to share whatever I know with you guys.
Okay, thank you, Homan. So for today's workshop, uh, will be basically there are some prerequisites, and hopefully you have completed all the necessary readings on JavaScript, TypeScript, HTML, and CSS, and etc. Because understanding this will actually really help you to understand and appreciate what React brings about to front-end development. So for today's workshop, we'll be covering on what is React, what is JSX, TSX, and the key React concepts such as components, props, and hooks. And we'll be learning all these through the process of making a to-do list app. So before we start, I would like to set the expectation for today's workshop. Of course, because we only have 2 hours, we'll only be covering important concepts of React. And the workshop aims to bootstrap you to get you started in designing a web app. And it will get you started in terms of the mental model you should have when you try to create a web application design, splitting a web into different components and binding them together as well. So, yep. So the format of the workshop will be as such. So firstly, Homan and I will be explaining the concept first, followed by some demonstrations. Then there will be time given, maybe about 5 to 8 minutes for each exercise to practice and to understand the code. The IDE we'll be using today will be Code Sandbox. As you can see here, the links to the wiki, basically the notes and uh, the code snippets are all at the bottom left hand corner. So you can just type in and get ready, get the web page, get this page ready for later. So before I start, let me just show you the final product that we'll be doing today. So this is the web page we'll be doing, and there are some features that we'll be doing. So things like adding a task, let's say, and you're able to click whether it's done or not done. So this is just a basic feature, and you're able to delete it as well. And other than that, let's say we have, let me just add one more. And as you add the task, you will also have to update the status over here. So we'll be doing this. And other than this, we are able to incorporate in one more features, which is to change the default user name. Let's say I can just type in ZhengHao, and yeah. So it's just a very simple to-do list app, and this will pretty much summarize what uh, the intro to the React, and hopefully you are able to get some insights from this. Go back to the slides. Okay, so what exactly is React? React is an open source JavaScript library used to build interactive user interface for web application. In short, it's basically a abstraction written in JavaScript to better interact in web application. And it was created in 2011 by a Facebook engineer, and it's very useful as it integrates very well with other tools like Redux, state management, or React Router for navigation, which makes it very suitable for large-scale application. React is used in many applications, such as, like those apps like Facebook, Netflix, Instagram, and the ones that are closer to us like NUS Mod and also Source Academy if you have taken CS 1101. So let me just do a brief explanation of how the web actually works for some of you that are actually newer to web development. So to start off, we have HTML which defines the structure of a skeleton of a web with the element, root, head, and body, etc. So then we'll have CSS, which pairs up with HTML to make our website aesthetically more appealing with all the styling and stuff. Then we'll have our programming language to add more interactivity and logic to our website. And other than that, a key concept about how web development works is this thing called DOM, the Document Object Model. How it works is that it enables the HTML code that is written in plain text file to be converted by the browser into a tree structure where it branches from, like, let's say the element, the head, title, text, and etc. Then the DOM created will further be converted to like UI elements the users are able to see on our web browser. And in the past, when you are trying to click on a link on a web page, the entire web page is actually reloaded. And the server will send back a new HTML file, even if, let's say, you only want to modify some parts of the page. And yeah, it will just refresh the entire page and it's very inefficient, which looks something like this when the entire web page is reloaded. So, and a very famous example would be the Wikipedia, as you can see over here. So let's say let's say I'm trying to click this button, view source, right? So by right, only this part, the body will be, let's say, modified and changed. But what this does is, you see, the entire web page will be reloaded. Yeah. So this is just an example. Okay, so now with the help of React, we are able to create a single page application. So instead of just reloading the entire page, the DOM is mutated using JavaScript. So only the elements that require change are being changed, to put it simply. So this is just like some very detailed explanation of how it actually works. I don't really want to dive in too much on this. We'll be sharing the slides after the workshop. So if you are interested, you can just read this slide. So how does React actually figure out what needs to be changed? Uh, okay, so how React does is that there's actually this thing called the diffing algorithm, which works very similar to Git. So what it does is it actually compares two items and basically highlights the differences between them. And I'll, what entails behind this is actually this concept called the React rendering. So React will act to this is maybe I will just use this image to explain to you. So uh, React will actually maintain a separate DOM called the virtual DOM on its own. So whatever changes that are being received, okay, by the virtual DOM within the React application, it will just compute the difference between the original React DOM, virtual DOM, and realize that the differences, which is in this case, are only the two nodes highlighted in green. So these changes are then propagated back to the browser DOM. By comparing the two DOMs, we are making very minimal changes to the DOM such that only these two components are being re-rendered instead of the entire web page itself, which improves the speed and responsiveness of the web application. Next, we will be moving on to React component lifecycle. So there are a total of three phases within this lifecycle. So every React component has to go through this stage called the mount when it's being added to the screen and when such that it's being rendered. And secondly, the component will update itself when it receives a new props or state. Usually, it is through an interaction when the user, let's say, click a button and stuff like this. So, lastly, it will be the component will unmount when it's being removed from the screen. So, why are we choosing React, right? Like instead of, like all the other uh, JavaScript libraries that we can actually use, like Angular and stuff. So, firstly, React is very fast. It prevents unnecessary changes to components. And a key contributor to this is that the diffing algorithm it uses is actually very fast. And besides that, React is also very intuitive, such that we are able to use JSX, which stands for JavaScript XML, which allows us to write HTML within JS. So, for example, in the plain JavaScript file, right, we actually have to write extra code to create, let's say, to create an element, create text node, and then finally we have to append the hello world text back to the uh, element itself, the div element. But then within JSX, it's able to identify, let's say, or like just combine uh, the HTML syntax and identify them, and we can just, write, like, just write it within just one single line of code. And it also improves readability when you are trying to, for like software engineers. And yeah, so this is just a summary of the pros of using React. It prevents the ugly reloading of the entire page. And there are a lot of support external libraries for for like React library itself. And when you're using React, the content of your web page, you can just simply divide it into many functions and components. And within these functions, you can just do whatever you want. Call an API, update a state, render a 3D model. And these are being done without like, you know, uh, affecting other components of your website. So in a way, it's just like building Lego blocks together. And yeah. And this also enforces a strict method for web development, which allows us to easily expand the current projects and also allow someone who has never seen the code before to understand what the code actually does. So this is actually the final, like let's say, the very dry content that I'm going to cover, which is the three fundamental rules of converting HTML syntax to JSX and TSX. So when we are trying to convert JSX or TSX, we actually have to return a single root element. So uh, as you can see over here, when there, when you are trying to throw this or like let's say run this, it will actually throw you an error because uh, within this app component, you are trying to return two elements, which is H1 and H2. But then a very simple solution to this is you can just simply wrap everything within a single element or single root. You can use either a fragment, div, or any other text you can possibly use which is suitable. Then the second rule will be to close text. So for components like this, you can actually close the tag with uh, slash over here, or but then and other besides that is for this particular like list item tag, you can just close it with a slash as well, which is I mean uh just the HTML syntax. And lastly, the final rule, which is also one of the more important things, more important uh, concept, is that you have to camel case most of the uh, keywords or like let's say the fields and attributes you have to use. So instead of the usual hyphen you will usually use to break two words apart within a single variable, you have to use you have to basically capitalize the start of the first letter of the second word, which is very similar to the Java convention we usually use. And lastly, for there are a lot of reserved keywords within JSX itself. So instead of class, let's say this is just an example. Instead of class, you have to use class name in this case. So there are like quite a lot of like reserved keywords. So you can just Google them if you are just if you happen to use them in the future or like you encounter an issue. Yep. So this is the end of the dry part. So now we'll just uh move on to the more hands-on part, where we will start coding. So before I actually start, let me just show you the sorry. Yep. Let me just show you the how you can access our code sandbox link. So you can just simply click onto this. Uh, it will direct you to a Google Doc, and you're able to view all the exercises that we'll be covering later. So let me just do an example. Let's say I click onto exercise 0. It will bring you to this page with like, let's say the layout is as such. So the left side, the extreme left is all the files that you have to possibly use, and the right at the center is where you can type in your code, and on the right, it's just easier for you to refer to. It's just the uh, showcase of the web application that we are trying to make. If let's say you have a double screen or anything, you can just just copy this page and just type it down, proceed to view. Yeah, and you can just refer it if you happen to have like double screen or anything. Yeah, but in this case, I'll just leave it over here. And other than that, when you are trying to work on the exercise, remember to just fork it out so that this will be the version that you're able to edit on. Yeah, and this is uh, essentially what Code Sandbox, how you can use the Code Sandbox. Okay, so before I start on the first exercise, let me just introduce you to the project structure of like how this thing works. So as you can see, you are able to see the public folder over here, which is basically it is being used to store all the static assets that you want it to be accessible for the final build without being processed by the Webpack. Then you're able to see the source folder. This is where you will do do most of your work, and this is where like all your actual application code lives, and this includes like components folder that you might be making in the future, styles, logic, and all the assets that are part of your build. And you are able to see the package JSON, which is like the heart of any Node.js or React project. And it tells the project manager like npm or yarn everything about your app's dependencies, scripts, and metadata. And lastly, you're able to see the tsconfig JSON. It's just a key configuration file in TypeScript projects, including React apps. Okay, so let's get started. So for the first exercise, it's just a basic HTML refresher, and you are basically what you have to do here is I've listed out the tasks, so you just have to fill them in accordingly. So for example, like the first task, you are trying to create a header over here. So this is the final product you should be able to see. Oh, yeah, this should be what you are able to see. So you are able to uh basically there are two components over here, the header and the body. So you are just basically trying to fill in this content, the header, the orbitals to do list, and whatever that you want to put in over here. And for the second task, yeah, you're supposed to fill in the top left box and the top right box, and also create two more tasks. So I've already given you one example over here. So within this table syntax of HTML, you're able to see that there's a table head already created for you, and within the table head, there's already a table row. And what you're trying to do is you're basically trying to copy this and paste this two more times, and yeah, just feel free to play around with it. Then I will start the timer now, and I'll give you about 5 minutes to try out this exercise. Feel free to just type in inside the Zoom chat box if you have any questions or like problems you have encountered. Yeah. So I'll start the time. Okay, 2 more minutes left. Okay. Yep. Now I will just do a run through of like how you should actually code this. So let me just open it up. Yeah. Yeah. So the first task is you simply just have to create a header over here. So you can just play around with it, and then you can just type down orbitals to do list. Yep, and it will reflect nicely over here. Then the second one will be to fill up the top left box and the top right box. So for this, according to it, there will be a mini header, wait, which is the overview, and following after it is just a small paragraph with text. How we can do this is just, okay, we just type it down. Welcome back from user. And we can create one more paragraph of this. Yep, and then you just have to copy the same thing, same code, same structure again, and paste it over here. Also, there's actually one shortcut in Code Sandbox is how you can auto indent is you can just press either Control S or Command S. So it will just auto everything nicely for you. Um, yeah, code of the day and yep, and some funny facts. Okay, yep, and it will just be reflected very nicely. And then for the last task, we simply just have to copy this table row 2 times and just manually make the do the changes, make the changes. So let's say like for the dog conduct workshop, etc. And you can simply just if you want to let's say tick the checkbox, right? You can just change the check to like let's say true. Yeah, and it'll be ticked nicely. Yeah, so this is just a basic refresher of how it should how HTML should be like. And yeah, hopefully you have like warm up and stuff. Let's move on to the second exercise. Yeah, exercise 1. So for this one, for this exercise, we have to understand how we can actually break code into different components uh, to basically, structure and group, make our uh, project more readable for others and for yourself. So as you can see, this is the final product that we want to do. It's just basically shifting all the code into, let's say, a header, task manager, which are like the respective components. So let me just guide you through this first. Uh, Second, so just click onto the exercise 1 link. And what you have to do here is actually, uh, first thing first is you have to create a folder named components. And you have to then because in this case I have already split the segments quite clearly for you, which is one header plus a main body. So you just have to create 2 components. You can name it any way you like, but for my case I'll just name it uh task manager dot tsx, and second one will be header dot tsx. So maybe one thing you have to take note if you are just new to basically JavaScript, or TypeScript is that when you are trying to export, let's say you have already declared a function over here, you remember to just export it, export default, whatever functions you have. And then back at where you want to use the code, remember to just import accordingly. And you just type in the like how you are able to navigate to the like the file system. Uh, yeah. Same thing. I will just give you about 5 minutes to complete this challenge, and yeah, and the time starts now. Okay, 2 minutes left. Okay, time's up. And once again, let me just run you through how you can do this. So, you have this. Just oh, yeah, close the wrong file. Yeah, that's fine. Let me just recreate, open this up again. Yeah. So first thing first, you just have to create the files again, the folders again. And then how you declare a component in React is, I mean, the easiest way is to just, use a function. And then let's say I'll call it a header. And you'll be returning something. And the usual convention we'll use is, you'll just bracket everything up, and then this is whatever code you want to just put it in. And then following after this is you just have to identify which are the header components, which is clearly outlined over here. Oh, sorry. Yep, from here, back to here. And what you have to do here is you just have to export the default header and back to your app. You have to simply just import it header. And how you usually declare a component is, as mentioned previously, is just declaring it this way with a closing slash over here. And as you can see, it's correctly reflected over here. Then you just have to do the same thing for the task manager. Copy paste the entire thing again. And boom, you have it over here. And you just have to Control S to auto format everything nicely. And you realize one key thing I want to just like just refresh your memory is that for JSX and TSX, when let's say you have multiple components, it will just throw you an error. So to no, you shouldn't be able to see this. It will throw you an error. Yep, it should throw you an error because you are returning like multiple elements in one shot. So what I usually like to do is I just add a fragment over here and it should solve it nicely. Yeah, it should work nicely. Okay. And there's also one more thing I would like to cover is that the concept on Pascal casing, which is very similar to camel casing. Is it's just that whenever you are trying to declare a component, a custom component, let's say, you have to you have to capitalize the first letter. So what if you actually doesn't capitalize this? Is that when and you're trying to import this, you won't be able to see your custom component. And usually how we do this is if you still like want to use the one without the Pascal casing, you just have to declare a curly bracket in between to declare that it's a TypeScript or JavaScript syntax, and you just have to declare a normal function like how you used to, and it will still work. But like the normal convention is to use component, the usual component way, the custom component way. So this is just something you need to take note of when you're trying to work on your project. Yeah, it should be nicely. It should work nicely. So let me move on to the second exercise. Okay, so next I'll be covering on states, which is I would say the core of React. So what state is able to help you as a programmer do is that it's able to add interactivity uh, to your web page such that as a user when it's able to let's say press a button or like I can input in like for example in our example we are able to add tasks to our to-do list which will be reflected accurately like whatever changes that the user want to add will be reflected accurately inside our web page. So this is what state entails. And it is, you can think of state as like the memory of a component. So within the component itself, it will memorize whatever variables or like key states it should have, and you are able to basically change it. So how I remember like using state is that first thing when you're trying to code it out, like from just pure blank file, is that you first thing you have to first import use state from React first, and after that you'll see this very weird syntax over here, which is like declaring a JavaScript or TypeScript uh, array, and you will see some state and set some state. So how this look like is that this is actually whatever data you want to store within this state, and the set some state is just it's basically the function that you'll use to make changes to your states or like basically the component you want to make a change. So here's a more accurate depiction of how it should look like. So when I tried to declare this and run it through the console or like just console log print this, it actually shows you this. So basically what use state outputs is just a array with the state, the current state that you have declared here, the default value, and basically a function that when you call it, you are able to change the whatever state you have here. So this is actually called method destructuring, such that you are declaring a variable over here and you are giving it a name, and as for the function, you are giving it a name as well. So let's move on to the second exercise. So over here, we'll just be covering on how to manage state and using the use state hook. Let me just open it up. I'll just do a short run through of how you should work on it. So just close this. So first thing first is that you have to first import use state from React first, which is already done for you. And secondly, you have to declare the two variables that's being enclosed within an array, either name or set name or like whatever name you want to use. And remember that when we are trying to declare state, you have to input in a default value as well, either a string, array, or whatever, which in this case, we can just use a string because we are just trying to uh, change our name in the user. So let me just show you the final product. So how it looks like is when you click onto this, you can just, it will prompt you something, a text box for it, or like input text box for you to put in your name. And once you put in your name, it's able to reflect clearly over here. So this is the basically essentially the final product that we want. Okay, where's my file? Okay, over here. Okay, then other than that, you also have to create a function that handles a click. So this might, if you're new, this might seem a bit daunting, but so I'll just do a guided one with you. So hopefully you can follow along. So first thing, we have already imported useState. So right now we have to just declare an array. And we have a useState over here. And because in this case, our initial value is just user, we're just typing user. And this will be accurately reflected if you are trying to, you can just input it in over here. which in this case, remember that I've mentioned previously is that when you're trying to declare you're just trying to put in a variable from which is in JavaScript or TypeScript syntax, you have to declare it within a curly bracket, and we will just put in name and Control F. It should be clearly reflected. Yep. And now it's done. Then now what we have to do is within uh this particular element, which is the paragraph, we have to add in an attribute. Okay. And basically we are going to declare our function over here, like whatever function we'll just put in here. So we'll just put something like this first. Maybe I'll just name it handle uh name click. And how we usually declare the function is usually we'll just put it within the component itself. So Fang, actually I can just use this constant handle name click. And what we usually do is we'll use an arrow function, which is very similar to the lambda function you've seen in you've taken 2030 as before. It's just something like this, and we'll just declare whatever you want to do over here. So as you can see, we are using this is because what we are trying to do here is we are trying to like create a delay. So let's say if you do not have this arrow function or like anonymous function, uh, what React does is whenever it will just keep running the uh function whenever you want, like even if there's no prompt or anything, there's no click or anything, it will just keep running through. So it just helps to, you know, create a delay effect within itself. And for those that are not very familiar, so with the syntax of so how do you create a prompt or like a text mini text box for users to input in their name is actually through this function called the prompt. So say I'll declare a new name and I'll just type in key in your name and then we'll just put it here name. So this is just a syntax. Uh, then after this, what we have to do is we have to utilize this function over here to set the new name. So we can just set a new state through this function and it should work perfectly fine. Let me just try it. Yeah, it works perfectly fine. Then now hopefully you have maybe I'll just give you 5 minutes to just play around with the code, read the code, and maybe just delete everything again and try out everything by yourself from scratch. Hopefully you can just do, like practice more. So I'll just give another 5 minutes on this. Okay, time's up. Yeah. Hopefully you have understood how to actually use state within React itself. Okay, so there's also actually just one more bonus that I would like to quickly cover is that there's actually a bug in this feature such that let's say yeah, when your name is in and just simply empty, right? You realize that yeah, by right, you are not supposed to nothing should pop out over here. So what we are able to actually do over here is simply just to uh use the conditional re-rendering which is simply just within, if I'm not wrong, it's over here when you're trying to set a new name. So let's say if your new name is null or like simply just empty, right? You can just key in this default value and it should work perfectly fine. Let me just refresh the page. So let's say if you have nothing over here, yep, and it should reflect default user correctly. Okay. So next I'll be passing the time to Homan to continue with the rest of the exercises. And before that, if I'm not wrong, yeah, Homan, you can take over.
In theory,
Yeah, can see.
right? Um, so like I'm sure like some of you haven't read the wiki yet. Uh so I actually wrote this like really comprehensive test sheet knowledges that you should know when you code in React. So I'll just paste this link in the chat. Or maybe ZhengHao can help me do that. So if you have one in your mind, I'll just go through something that you should know, you must know. So first, there's two ways to describe an object in TypeScript. So types and interfaces. And if you look at the code, they're pretty much like the same. But actually they have like different use cases. So for interfaces, it's more on when you're working with the object-like structures such as props, like component props, and API response types, as they are very structured and can actually describe them like an object. So and interfaces can also be used for like a parent class, child class. So but as it can be extended like using extends. So for example, we have a user interface which has ID, name, age, and they want to offer more properties on top of user. So we can simply just like it's just like OOP, which extend the class that introduce more properties such as year and is verified. So for types is you can think that it's more expressive. So you can use type when we are dealing with unions, primitive, or when counting complex types. So so just now Zheng share how you can declare state with a certain type. So for example, uh let's say you have status, um you want to introduce like three different like enum like structures. So you can simply like using this union, which is like this thing here. So status now take in loading, success, or error. And since you declare the type properly, right now the compiler knows like what are the possible values you can take in. So if you look at this example, we log please wait when the status is loading, right? Also, another trick in TouchRate that is we use this thing called restructuring very often. So for example, we have a user interface that takes in name and age as the attributes that we declare it. So instead of doing user.name, user.age every time, um, there's a cleaner way to like to retrieve like these variables, which is simply just destructuring the interface. So the syntax is something like this. So we on the right hand side we put in the user. On the left hand side we just simply destructure the properties that we want to use. So instead of like doing like Hans name equals to user.name, we can simply destructure it in a cleaner way, which we'll be using often in to destructure our component props. Also next, is this thing called spread operator. I'm not sure where. I think ZhengHao covered it a bit. Um, so it's just like a feature in JavaScript or TypeScript that allows you to spread the properties of an object. So what does that mean? So basically think of when you do, so let's say we have a user that has like the name of Alice and age of 25, and we want to update the user. So instead of like doing like user.age equal to 36, we can actually um spread the previous users. You can see like there's a triple dot which is spread all the properties of a user into a new object. Then we can simply overwrite the edge property at the end. So because in React we compare like the values how do I put it? So basically objects are immutable. So there's no if you mutate the variable like specific variable directly, there's no way to React no you have to make some changes. So usually if you want to update some values in TypeScript, you basically have to create a new object first, which is by sharing the previous properties of the previous user. Then and later you just update that variable. Yeah, so that's for like single object. You destructure a single object. But also you can also destructure an array. So anyone want to guess like what's inside the list now? So the answer is just the updated to dos will be buy milk and walk dog. So basically in here we destructure the array of string. So basically we destructure like an array of string to become like elements. So like it kind of like they are flattened in now. So it won't be like a nested array and such. Also muting state. So in TypeScript we deal with types interface like a lot. So usually here when you try to like this is actually part of the exercise later, but just giving you some idea now. So basically we'll get to use interface to describe like like to do. So you give it a title and a done variable. Then in use state you simply just declare like the type here using these parameterized types. Yeah. Um then actually there's like three really clean ways to use the update to use function, so, which is in the second argument in the use state. So first thing, set to dos. So if you don't depend on the if you want to update some state that's not depend on the previous state, you can just simply for example like our do is now taking an array. So if you want to just override the initial do with this array um of one to do, which is has a title of new to do and done force, we can simply do it that way. But what if we want to append some element to the array? So previously I covered that if we just mutate like the state directly, like the React wouldn't know we make some changes. So we have to use the spread operator here. So like the second example is just like a way of showing you how to append or to do in the state. So usually you can see like the second and the third way is pretty similar. But usually my rule of thumb is if you realize that the so oftentimes most of the time I'll just try to use the third way to do it. And if it spans like across multiple lines, I'll just simply use the second version, which is like slightly more concise and more readable. So basically here, like set to do's, actually also we can also take in I'll show like I'll talk more about in the section later. But literally you can so instead of like referencing from the state um that we expose here like to do's, we can actually use using the callback to retrieve uh what is a so at the time we updating this state, we will have reference to what is the current value of previous to do's when updating the state. So this way is preferred as it will ensure us we are always working with the more recent state, especially like inside like we're dealing with async operations. So for example, you click a button 10 times. But if you're depending uh on a state, on a global state here, for some reason, like if you click too fast or something, it might be only updated like 9 times, for example. Yeah, so I think this is really important. Like so instead of like re- depending on the global state, we use this callback function uh to reference uh with the state at the time we updating the state. And yeah, if you want to read more about all these, you can go to our NS Hackers. The link is something like this: wiki.nshackers.org Orbital3. Yeah, but these are the most essential one that you must know and you should know already. Yeah. So before I move on to exercise 3, so so um so let me show like what's the end product. Um, so usually at the end of the session, we will be able to add some tasks. Let's say just create some tasks here. We'll be able to update the state. Also, just now we have shown like how we can update the state. We'll be updating us. We can update the state also, update certain to do, and also delete them. So basically, it's called CRUD, which is we'll be able to create new items, read the new items, update the items, and delete items. So think of like this as like any shopping cart feature in the shopping app. So think about you have a global state of your shopping cart, and just deal with that state um in different parts of the app. So we'll be taking like 3 to 4 minute break now. It's like a bathroom break. So before that, if you have some time, you can start to read on the exercise 3 a bit. So you can click on the link here. It's like exercise 3. Yeah, so we'll be having maybe a 3 minutes break. Yeah. So meanwhile, like just let me know if you have any questions, like any part I should explain more. Yeah. right. So let's now work on the exercise tree. So um so for this exercise, so if you look at the current code now, everything is like kind of like hard coded, and we definitely don't want that, right? Like in our app. So like and so in for this task, we want to display. We will first create some initial to-dos like on our end, and we try to display that programmatically, and 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 try to create a task component to make it more modular and extensible. So I don't think we have enough time for to later try out on your own for every exercise. So I think for this exercise, I just like will be just guided. Yeah. Um. So first of all, we can uh. So I think a good example, I like a good start is always try to create an interface first to describe our object. So in our to do now, you can see uh we will take it, we have a description to describe the task, and also a checkbox value to describe whether this task has been completed or not. So we can just do like uh we can just call it task um string boolean. Yeah, yeah. Um so like that's like the first thing that you should do whenever you're dealing with objects in TypeScript. Then next, let's create like a state here. So actually, you don't actually have to write like import functions on your own. You can just like click and like the ID will do for you. So also we need to specify um our type for our task. So it's like array of tasks. Then initially it will be empty. So for this it can actually be anything. Um like if you want to call like, for example, you can call ABC, say ABC, and it still work. I think but it'd be better if you name it like so it's more readable in a way. Yeah. And right now let us create some initial tasks in our app. So how do you declare it? Um so let's give it a name like called intro task. Then the type is an array of tasks. Then since we have typed it properly, so right now ID will help us to autocomplete. For example, uh if I put in a number here, there will be some error. You can see like the task title is string. So when I save this, it should give me some error. Um, the first task. And same for Boolean. You must specify like a Boolean value here for false. And I'll just copy this. And let's change like the one to two. So so a good way when you do your uh when you do a development is always open the console. So you know like what could be possibly go wrong with your code. So right now we can see we will try to print out what we have declared just now. Okay, so for now just ignore this warning first. So you can see right now we have a array of three objects just as we declare. So then now we can replace this initial to do this empty array to the initial task that we just create. So right now we change this to task, and we should see that let's refresh. Let me make it bigger. Yeah. Um. Yeah. So right now to make it more readable. You can see right now the task just as you declare. So next step, I want to introduce this thing called prop passing. I think ZhengHao covered just a bit just now. So you see right now everything is kind of like redundant here, like and it's hard coded. Hard coded means like so no matter what state have you changed, it's still show the same thing. And then we can find a similarity here. So for each like row here, it's actually uh a tr tag here. So what can we do is actually we just create a new component to describe each task. So for example, so how you can create a new component is you go so usually is sit under the components folder. So we call it like task component .tsx. So and first thing, you do something like this. So basically, we just telling and make sure the extension is TSX. So the component node we are coding in React and it will be using JSX. Yeah. So for each task component, so let me just copy this code over here. Should return this. But still run is hard coded, so we must change it to the actual value. So how do we do that? Uh, and since we have already like created this task interface here, we can try to exploit it. So it will be accessible to anywhere else in your app. So now we can declare like now we have to tell the compiler what does a task component takes in. So ideally you take in a task uh let's call it task component prop, and you take in a single task. And we can just do something like props, task component props here. And just now we learned about destructuring. So we can actually do something similar here also. So inside props, since we have typed everything properly, right now we know prop is that we can receive a task here. Then we can do another destructuring, which is we destructure the task again. Um, then the compiler will tell us we have title and done here. Then now we can just change this accordingly. Uh, so we can do something like so initially it was just hard-coded, right? So to make it more reactive and use a JSX, you use these curly braces here to specify the value we want. So for title, for the hard-coded, you just replace it with title, and the check value here, we just replace it to done. Let's try to save. Yeah, there are no errors. So right now we have like completed our task component here. So the next step is to refactor this whole chunk of hard-coded code here. So right now we have an array that takes in okay, it's not working. Let me refresh to show you some hints. No mind. Uh, okay. So basically, we have to refactor everything here. So we can leverage this thing called map. So if you have taken 2040 BC, the map just taking a transformer to translate. So here we have a array of tasks. We want to map that to a list of components. So this we have taken a single task here. And then we'll be returning task component. which will take in a single task. Right. Let's see if this works. Oh yeah, the task component not compiled because we haven't import this yet. So we can just do import from. So basically it tell us like so right now we have the components folder. We can just access that from the task component. Yeah, right now you see that the state has been reflected correctly. And there are six now because we haven't removed the hardcoded one. So let's just do this. So just remove everything from. Yeah. So let's start looking at the warnings. Yeah, also we'll try to do map. So we actually have to um put in a key here. You need to just tell React that so I think it's more effective when they are rendering internally. So basically it's a way for React to identify um each component. So we need some key that you need to identify or describe that specific task. And since we don't really have any ID here, so the best way is we can leverage this thing called index. So basically in the map here, uh the second argument here actually gives you an index. So it's basically that this task to map returns you um the first task and then index is zero and so forth. Then we can pass in this index here. Then right now the warning should disappear. Yeah. So we can't just ignore this part here first. So let's try it out with like more to dos. I realize this when I save this. The state here there is still like three tasks here because so when you declare a use state here, the initial task is only read once in the beginning when you want a component. So to see the effect, we actually have to refresh the web app. Yeah. And we see there is some small bug here. Uh like so actually now we have to pass in another like index here. So we can just take in another props, which number. Then again, destructure it from the props and display it accordingly. Now back to task manager. Yeah, okay, now you can now see like we're actually passing some actual value here to a numbers column. And since this app is not just for programmers, you can just like plus one for the better reliability. Yeah, I think that's it for exercise 3. Like any questions? Um yeah, if not, we just go through the next exercise. So for exercise 4, um so for exercise 4, we're going to implement the functionality of adding a new task. So just now you can see our state here is we still does not have any um functionality to add new task. And in fact, when I try to type anything in the input box, it just doesn't work um because the value is always an empty string here. If you look at this part. So so for this like session, for this exercise, our chooses what is read events, per operator, um and what is how browser default behavior um in a form, and how do you prevent that from happening? Um So right now let's fix the input box here. So the ideal outcome is when I type something, it reflects it accordingly. So now we have to um create a new state, or maybe call task name, which take in a string. Initially is empty. Then we can pass this this state here. So let us change the initial like values. You let you see like for example task initial task. You can see it reflects accordingly to the state. So like this compiler is right now reactive, right? So let's remove that first. And the reason why right now still where uh it doesn't change where type is because we still haven't updated the state yet. Because you see right now, see the set task name function is actually played out. So that means we haven't used it yet. So you see type compiler is saying it's declared but it's never used. So let's create another function for handle um task name change. So basically just create an arrow function that um that may take in some value and we process it accordingly. So actually input has this API called onChange. Yeah, here. Which so for example, you can see like the onChange here are some callback functions here for event which has um which will fire every time the input box has changed something has been modified and has some new values. So because we coding in TypeScript, we must specify all the type for every um parameters that we use. So we can simply copy this type here. So how it should do it is event change event. So and then you might need to import something that is import something. So how you do that, you see like there's some red squirrel lines here. So you can just simply do command. So if you're using that is command dot, then you give you the quick fix like pop out. I think if you're on Windows, it's probably control dot something. So anyways, we can just update import from React. So you might be confused like how do I know um um whether like whether this thing new exists, like how do I know whether there's such thing called change? But actually this is more like a HTML implementation. Yeah. Uh, 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 so we can now test it. So give us some what does it treat us? So let's open our console again. So let's type in something. Oh, we our code our function yet. So right now, since we're doing the function that we declare ourselves, you can see when typing something is show out on the show in the console. Yeah, the reason why it's only showing single character is because we haven't updated state yet. So our empty state is already empty. Uh in order to make it work, we just simply set task name event.target to value. So right now our input box should work now. Yeah. So the next thing is how do we so ideally we try to so I test one thing. Ideally we try to when I press on the add button here, uh um it should be added in our task list, right? Um so let's clear this warning first. So this line. Just going. Can you know this for now? No worries. Um, and you realize that there's some word behavior. So we're trying to press on the add button. Sorry. Um, the page refresh for some reason. And that's because we are using a form here. So the default browser behavior is we try to submit a form. Uh, we try to submit a form. The page will actually refresh and um React honors that default browser behavior. So, but here we definitely don't want that because there are two reasons. Our states are local, a client state. So every time we refresh, um, the previous state will be missing, will be gone. And secondly, it just has a very bad user experience. So I type something, it should append to my list, but somehow what I see now is just refresh the whole page. Yeah. So it's not a really good it does not have a really good UX experience. So how do we fix that? So first of all, we have to make this button um as a as a submit type. Um, so we know that when we click this button, we are telling the form that we are submitting this form. Then let us create another function for handle form submit. So again, we don't know what parameters and what is it types that we're taking in. So we can always do this tag. So um so now you see like event actually return us a form event and has a type or HTML form in the element. So we can simply copy this again, um import import this function, import this type, I mean, then we simply replay this. So right now let us do some checking to see whether we have done everything properly. So console, we can do some logging here. Form submitted. You can see form submitted and immediately refresh. So how do we prevent the refresh like behavior? So we can just do it event or prevent default. So right now we're trying to add a new button. You can see like form submitted like multiple times, and um the page does not refresh anymore. So the next step is so ideally where we have submitted the form, I will be appending a new object to our existing to-dos. So let's say if I add something here like play with cat, and let's print this out, task name. Um, I should be adding this new task play with cat to our current active task list. Right now it doesn't work because we haven't handle that part yet. You can see like the side task is still grayed out, means we haven't used it. So how do we do that? So just now we introduce like a spread operator. So how do you take a list is basically set task. You can see right now actually we can take in a callback function here. So for example, like we can call it previous task. So we hover on it. You can see that we do have access to the previous state. So that's what I mean just now, like in the slides. I talk about how you should mutate a state. Um, when you're dealing with when you're referencing previous states. So let's do the same thing here. Um, previous, so we have access now to previous task, and so for this task, we have to return like the list of tasks here. So basically, we just spread the previous state, then create a new object because we are appending. So uh we'll be creating an object here at the end of the array. So so we should take in title, which should be named task name, and done by default is false. Then also since we are submitting a form, we should clear the previous input as well. So we just simply set task name and D string. Yeah, right now it should work. Yeah, you can see we are able to appending the a new task here. Drink coffee. Yeah, so right now we have added the add task functionality here. Yeah, but because it's a client state, every time we refresh, the previous state will be lost because we right now we still haven't processed the state in either local storage or with an external DB. So we'll be covering that part, how to persist our data in web dev in the next video workshop. So no worries on that now. It's no behavior because for now you lose your state um between different refresh. Yeah. So I think the workshop will run a bit late today. So I'll try to speed things up a little bit. So the next exercise, we'll be introducing conditional rendering. Um, so 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 this ternary operator is just like a simplify if statement that return either values depends on the condition. So the syntax is something like condition. So you write a condition here. Um, then you return some value, if true, and then the semicolon, especially if false. Also for conditional rendering, we have these two operators that we use very heavily in React. So two question mark means a knowledge operator. So I'll be going through that later. So basically it's like if the previous value, so for example, if my code is something like, for example, I some variable here. If the value is in null, I'll be uh um I'll be use this value instead. If the value is null. So that's what you call like knowledge operator, I guess. It's not like the most straightforward term, I think. Also logical and so basically it's similar as knowledge operator, but we only return so the syntax is something like condition, then and operator, then something here, return something here. Yeah, the syntax is something like this. I'll be going through later. Yeah, so for this exercise 5, so if you look at it now, so since we added uh the add task functionality, let's remove the initial task, or rather just change this back to an empty array. So right now you can see like our task is empty, but it looks kind of ugly, right? Because I had no task. Like, what's the purpose of showing all these tables? So around is like the time we use the conditional rendering. So basically, you want to hide all these when there's no task. So how do you do it? So always start from these like curly braces. We want to deal with um actual state or like variables. So the one that fits the most is probably either this ternary operator or this logical AND. So for now, let's just use logical AND. So we have some condition here. So we want to make sure we only want to show like the task list if the task dot length is greater than 0. So that's how you use this ternary operator here. So either this or we can just convert this into a ternary operator. It's very similar. But right now we have to return something else if the task length is 0, for example, or like less than or equal to 0. Just return like, so let us like return a D. Then saying like no task yet, please add something. Yeah. But that's kind of ugly because they don't do any something. So let's stick back to the AND operator. Yeah. So we add something now. means my task length is greater than 0. It should show something. Yeah. Then by default, it shouldn't show anything because there's no task. And also, um, you'll be using the acknowledge operator for the username. So let's go to a header component. So you can see that right now the initial state is so actually if you are using a primitive, so React actually knows like React will actually infer this type. So you can see like the night. If you hover over it, the name is actually a variable or string. But what if you want to like introduce like different variables, like a rather more complicated types? So then we can just declare it. So we can take it either string or union of now. So the motivation is because uh I can just call myself default user. And so um from the perspective, we don't really know whether user has set their username yet. So a better way is actually leverage this now variable. Okay, but now it's kind of ugly because when the user haven't set anything, uh it shows nothing here. Then we can use the null operator, then just call it default user here. Or like anything you want here. So right now we know at least so if the name is null means the user haven't set any username here. So let's change this accordingly. You can see now is correctly reflected. Yeah, of course we here also have to handle, of course they might empty enter string. So I'll just handle like if new name is empty, we only update the state when the new name given here from this prompt API is not empty. So let's refresh again. Should not happen. Oops. Uh, Maybe an operator. Yeah, okay. Now you can see like uh when I don't insert any name here, it doesn't update the state. It's still showing us default user. The user haven't updated their name, for example. Yeah. Yeah, so this is conditional rendering and just a very simplified if statement. Of course, you can always do like, for example, like just now the part, we can do something like if pass.length equal to 0, then return something. Then return, for example, some pass here. Yeah, but I think turing operator is just a cleaner way of writing or simplified that if statement and logic under this part because your component might consist like some code from other part also, and it's rather like a cleaner, elegant way of dealing with that conditional expression. Yeah, so that's it for exercise 5, where we cover like internal operator and conditional rendering with knowledge operator and logical AND. So let's go to the next part. So right now, um, if you have realized it, and the console has been complaining like we haven't implement this, so let's add something. Uh, actually, I fixed a value, fix that warning. But never mind. So whenever you toggle this done checkbox here, it doesn't reflect a containing yet. That's because so right now we only have dealt with the add task functionality. We haven't dealt with the update functionality yet. So how do we do that? Uh so let's look at the task component. And we have an input here. So similar, um so we need to listen to this checkbox on change function here. So same thing, we can always copy this type, call it event, and import the type, and just call it um let's name it better handle change handle toggle, for example. Uh, so right now we know something has changed here. So for example, I will see like what does this return us event or target the value. Uh, oh, error functions. Wait, strange. Unchange, enter toggle. Um, a minute. This is exercise 6. Um, oh yeah, so I think that's kind of strange. So when I click this, when I try to modify this value, oh I know, I think I know why. It's not called unchanged. Uh, wait, I think. Oh, let's try this. Start refresh. It should work actually. Unchanged, handle toggle, checkbox. Maybe noise function. It's kind of strange. Uh, Wait, let me debug this for a while. So ideally it should print out something, but this doesn't like work at the moment. Uh, Type check unchanged. Try to add a couple more. Wait, that's really strange. So ideally it should print out something. So unchanged. Wait, let's disable the check really. Console. Is my console not working or something? I render. Oh, we should even print out something here, like this. Oh, surprisingly, I think for some reason my console doesn't work. Uh, like so even when rendering this task component, it should bring out this render thing. Okay, never mind. We just call it in black box. So ideally, it should log out something. We'll try to toggle it. Um, but let's look at our current component diagram. So we are at here now, list of task component. Then we realize our state, where we control our state is actually like one level out, like at task manager. So how do you notify? So it's like from child to parent. How do you notify task manager some state has been changed? So so for props, we not only can pass down like some class objects, we can also pass down our functions, which we call it a copy function. So so at here, uh handle, we can actually declare like we can actually so from props. So let me just point out handle toggle callback. Then you take in an index number. So they will destructure it. So whenever we do this, handle toggle callback, uh, also passing the index. So whenever we try to toggle this, it will tell the parents, oh, hey, something has changed from the child. Here, please update. So let's go back to task component here. So handle. So since we have the pass out function, handle toggle callback. So let's just declare that function here, handle toggle task, which take in an index of number and a function. Uh, then let's pass that handle toggle task. So error should disappear. So same thing. So you can copy so right now we have to so okay, imagine and let us try whether the login is whether works now or not. Okay, I think for some reason this console doesn't work. Oh, okay, finally the console finally come back. So if you do a login here, so whenever I press something, let's clear this. Uh, there's some value printed here. So now we know. So now we know like we are correctly passed down the callback function properly. So every time when I try to do something, when I do something in the child component, my parent knows it. Like something needs to be modified in the index. So of course we need to update the state, set task. And since we are dealing with we need to mutate the previous state. We need to use this call function, previous task. So same thing, we also have to return an array, like similar as at the end you touched just now. So this is a little bit tricky because so um let's say we have like different tasks, 1, 2, 3, X. So X is the one that we want to update, 4, 5, 6. So what if like the task, so this is different from the new task, where we can simply just append that at the end. But what if we want to update some specific uh like do at the middle? So we can use this thing called like sublist. So basically, period task is called slice. If you read at the API, it's basically returns you a copy or section of the array. So we always start from 0, 0, and until that index. So the end here is, I think it's exclusive. Then same thing. So at the middle is a task that will be updating. And so we have to handle the session here now. So will be period task dot slice index +1. Then up to like the end of the array, which is task dot length. Yeah. This might give you some flashback for your 2030 PE. It's something similar as that. Yeah. So right now we have to update at the middle. So and since we only care about the done toggle here, we can just simply spread that variable. So right now, so um destructuring this like spread or like spread operator here. Spread like this specific task. So right now, this will give us like the previous to do, but the previous task, but we want to update something, right? So for example, the done here will be toggle. So let's see what's this error. Oh, okay. So same thing. So right now this return us like whole list, but we want to flatten it. So then we just simply use spread operator as we learned just now. Yeah, then you can see right now the error has just gone away. So let's try as a new task. Then you try to toggle it. Then it should work now. Oops, it doesn't. Oh, handle toggle task. Okay, let us solve this part first. Task manager should have a key here. Try refresh. Oops. So let's see what's the error. Yeah, so it does load the thing properly, but I think for some reason, uh, let me see what's the error. Um, Slice zero index plus one. Stop. Oh, maybe. So later just change everything. Zero task, zero task. So instead of relying on the state here, we use everything. Use a brief task here. Oh, still doesn't work. Okay, that's kind of strange. Um. Oh, I know why. I have to pass in this. Not done. Yeah, that's my bad. Uh, yeah. Finally we have get these like toggle functionality work. So in this section, so for this exercise, I think you just learn like what is callback function. So because the reason why you need a callback function because we can't mutate the state here because we don't have the access of set state here. But I mean of course you can just passing down this function here. You can passing down this function here, but it's usually not encouraged because you rather have like a single place that handle all the logic. So for example, like the task manager just handle all the update logic instead of like we are just programming that to your children to update that. So I mean I guess that makes it harder to debug. It's not completely wrong. It should still work. But usually we just use callback function so we can actually control everything in one place. Yeah. So like questions? So that's what exercise five. Basically you just learn how to pass in callbacks and learn more about immutability. Oh, so actually we have another button here. Um, let's do that now. So let's go to task component and let's task manager. Then we added another like column here. It's called like let's call it delete. Right. Then let's go to task component here. Same thing, we also add another TD. So let's create a button and delete. Yeah, so same thing. Um, we will need to pass back or delete callback also. So actually, um, we can even like do something like we don't even need this function. We don't even have to create another like function here. We can just do this. So just copy this. So let's fix this syntax issue. Yeah, it should still work, I think. Yeah. Then similar thing like button here. So every time I click this delete button, I'll fire this on click. So on click will be fire. Then we can do some logic here. So we can use anonymous function. So same thing, destructure the props under delete callback index. I pass in index. I think it's important that you realize why we use index instead of task because we need a way for the task manager to know like which specific uh task has been mutated. So same thing here. Okay, right now see there's some error here that you can see like handle delete callback is missing. So let us implement that. Handle delete task. Also taking a argument of index. Then same thing, we just copy everything here. Then right now, since we are deleting that uh specific task, we just delete the middle part. Yeah, so right now let's try out the delete button. Let me add a couple. Yeah, so right now the delete button is working. So instead of this way, there's another like little way to actually do it. So uh you can leverage um this thing called like serious this thing called filter, which basically takes in like a predicate. So right now, uh so same thing is similar to map. You can hack in two arguments. Either like so the first one is a task and the second one is an index. Then you simply want to just let's rename it so it doesn't uh it's not the same. So the predicate here is we want to filter everything as long as the task index is different from the index we want to delete. So let's call it the index for better clarity. Index. Yeah, so this reward also is just like a different way of like doing stuff. Like I mean, I guess even you can just like do like a tedious like for loop thing. But in that way I think your code will still work, but it's just um more tedious to write that because you can leverage all the JavaScript API, such as like a slice or like a filter function. Yeah. Yeah, so that's it for exercise 6. So let's rush thing out a little bit. Sorry. So wait, I think we're finishing soon. Maybe like another 10 minutes and stuff. So let's go to exercise 7. So we still have one part haven't completed yet. So if you have realized, so no matter how many tasks we add and like toggle the done functionality, you can see like the overview here. Uh, it doesn't correlate like the number of incomplete tasks, right? And it's actually at the header here. Right now you can see it's hard coded. You have like one task that are not done. No matter how many tasks you add, how you toggle it, it still always show the one task. So but we actually run into one problem. So this is our current common diagram for exercise 7. You can see that the place we currently initialize the task state is at task manager. And then um we actually passing down the task to task input and task list, right? So and the reason we can do that is because we're passing down that props from parent to children. Then how do we pass that props to header? And I can see they're actually siblings. So like their common parents are at. So I think right now there's no way you can actually pass out props except we put the header uh under as a chair or task manager. But that's kind of break everything because um they're just at different parts of the app. So you can see that right now is the first part is the header, which is like this part. That everything else is under task manager. So I'll introduce this concept called lifting out state. So so instead of like instead of like making header as a children under task manager and makes everything much uglier, we can actually lift the state up. So instead of like initializing the state at task manager, we move one layer out. So we shift the state, use state function for task, and add. Then right now, since right now, the header component is a children of app, we can actually pass down that task as a props. So that's magically solve our problem, right? So let's do that now. So first thing, we have to refactor. Basically we have to mostly go. There's a lot of copy paste here, so we have to move these tasks over here first. So let's slowly refactoring. So do the import. So for the task, is currently declared at types.ts. So let's just import that from types. Then it's just for tasks. Right. Then the next thing is we have to move all the logic. Like for example, like NU task, handle toggle task, handle D task. Because uh usually you have to just shift everything over. Because right now this app is actually essentially like a task manager because it controls all logic related to tasks here. So let's just slowly refactoring. So let's remove these tasks. They now realize that the NU task now has a scroll line. So which means we have to use this um we have to use the power of callback function again. So let's create a props for task manager. Add new task. You can see right now it actually texting a task string. Then we can just do uh then same thing. We destructure the props, add new task. You see right now the uh squirrel line has gone away. Then right now we meet another task. We have met with another issues. So there's also squirrel line for task. So same thing. We just pass that now as a props. And same thing, destructure it. And there's much more. The handle toggle task, handle delete task, which also has squirrel line. So let's just do that as well. Handle toggle task. Which take in a task, which take in an index, I think. Oh, and task and index. So same thing for handle delete task. So let me double check whether, yeah. So same thing, destructure it, handle, delete task, handle, toggle task. It's because we have type edit property, so the auto like the IntelliSense like is working like properly. So next things so these are props for task manager that we must receive from the parent. So same thing here, just passing down uh like props one by one. So they pass in any task. You can see around is a lot of auto completion because yeah, as mentioned, because we're using TypeScript. So the compiler like do a lot of work for us. And those toggle tasks. Yeah, so right now you can see like we shift the state out and uh currently there's no error with the app already. Let me just quickly check whether all the functioning is working. So the toggle is working, E also working. Then right now, so let's go to the header. Uh so in header, we also need to retrieve we also had to know like how many incomplete tasks are there. So also we will start from like introducing the props for the component, header props, which will take in a list of tasks. So import, yeah, import the task. And right now, same thing. Please calculate. So now at the header component, we'll be able to access the task state here. So let's go back to the app. Yeah. So hopefully this will clear all the error. Yeah, so run has no error. And under the header component, right now we access to the task on state here. So every time I add something, you can see retrieve something here. So right now let's just count. Let's replace this variable here like one to actual state. So let's create a new variable. So let's call it number of incomplete tasks. Then we can use the SV API call filter again, as what we learned just now. So since we want to count like the number of incomplete tasks, so we want to filter out those tasks that has been completed. Then eventually, I want to this variable should be a number at the end. Then so after we do this, so this task of filter task returns us an array of like incomplete tasks. Then we can just do dot length. So this is being calculated every time we render this component. Yeah. So right now you can just pass that variable in. Number incomplete tasks. So right now he has been correctly reflected here. He has 0 tasks that are not done. Just let us add a couple more. Toggle with the functionality. Yeah. And that's because we have lifted the state out. So we had a task manager, task input, task list, has access to the task and a corporate function. Through the corporate function and by passing down the state through props. Yeah. So any questions for this? I think I'll just rush like the last exercise. So task 8. So finally, we close this workshop. We will teach you guys how to fetch data from an external API. So right now, actually, you realize that we haven't done anything to this like section yet, from finding things or like any codes or whatever. So how do we fetch data from an external API? So we can use the browser native fetch. Like it's from the JavaScript API. So it's a built function that exists in all major browser, and it can be used to make API calls. So basically it's just this syntax. So like the API we'll be using is this. I'll just paste it in the group. So it's just some random cat fact. So if you put this type this down in your browser, it actually return us a JSON, which is called JavaScript object notation. Yeah. That return us like a fact and the length. I'm pretty sure this is like a character's length. So we are going to use this API. So what happened underneath is every time I type this in, it sends a GET request to this particular API, which returns us this some random fact. Right. So that's the API that we'll be using. So for the asynchronous and return promise, I'll be explaining more later. So I'll introduce another React hook. So far we have only covered one React hook, I think, which is use state. But so use effect is basically perform some side effects in function components. So for example, just quickly show some example. So basically the syntax is something like this. Make sure you import this as well. So if the second arguments here is actually like dependency array. So anytime, for example, if it's empty, means it's only going to be fired once, which means when the component mon, for example, like log here component mounted. they will see something in our console. Yeah, and it's going to be, and it's only going to be like happen once, like fire once. So um we can also like specify like, different dependency here. So we are concerned like so whenever the name change, we want to do some side effect. So it's usually I think most of the time you don't really need use effect. So uh when when I use effect any projects or I work or like internship, it's basically we are want to do some logging. So for example, when users change their name, uh we want to send some log to our backend servers for processing. So that's a great motivating example on why when do you need use effect. So can load something like name has changed to name. So let's refresh again. So you can see like it actually fired twice. That's because we are under the death mode. So don't like scratch your head if you see like this effect happens more times. When you are doing that locals, it'll be fine if you deploy it. Uh, if you deploy well, you just work normally. It worked twice. It fired twice because we are under the death mode, right? So let's change our name. Oman. You can see like some I've been out name has changed to Homan. So it's basically some side effects. So we want to introduce some side effects when something in your dependency area has changed. So yeah, so that's all for this effect. So right now you might have like one question, like how does this like what's the relation um between this and the calling API? So we're going to be leveraging this template. So uh so it's just as simple as that. So every time I loaded this page, I want to make an external API call to this website, catfact.ninja fact. Want to get some catfact from the API. So I want it to only happen once. So we can just simply um use effect to help us achieve that. So like since catfact is going to be a string, let me just quickly write it out. So same thing as like oops. So the type either can be string or null. So initially it's null. So now we know like if it's null yet, it's either we haven't fetched the API and update the state yet, or either there might be some error when we're calling the API. Right. So I think using now is a very important um practice because it clearly differentiates whether this variable um has been used or like replicated, for example. Yeah. So yeah, so they'll just like let's just make an API call now. So let me just copy this. So okay, for right now, so if you look at fetch, it actually returns us like a promise, which is very similar as your completable feature. If you're done related me, it's just as similar as that. So then for then is um so if we got a response from the API, uh so actually we can just like look at the network tab here, refresh. If you look at the raw response, it's going to be like super long and include all the different uh different variable. So we had to pass in that to JSON because in JavaScript we deal with JSON for the API responses. And then so this is just like so at first fetch return us a promise. So when it's completed, then we will pass that to JSON, which return us data here, which is what you see on the screen. like this JavaScript object, right? Then uh then they want to the only thing we are concerned here is just the fact here. Then you can do data.fact. So you can see now my console is already like showing something here. Uh yeah, same thing. It run twice because we are under the dev mode. So don't be so concerned about it. So instead of console log now, we want to update the stack. We want to update the cat fact. So just data.fact. So let's just remove this. Some cat fact. Then update this. Oh, so okay, so the reason why this kind of my bad. The actual syntax is wait, it's just not this. Is we should put this function under the error bracket. I think just now I put here or something. So that's yes, you see that like um fire more frequently than you should. Yeah, so right now you can see so when we first uh load the page, it's initially empty. Then we make two API calls. That's because we are under dev mode again. So we can also show like something meaningful to show like when we are still fetching the cat fact. So can use a knowledge operator that we have learned. So it's probably a default value if this cat fact is null, right? We can say something like loading the cat fact. So we refresh, we will see the loading cat fact first. Yeah. So yeah, I hope this gives you some idea like of use effect. Basically, we want to run some side effect when the component is mounted, which is we want to make some API call to this cache to this catfat.ninja slash fat. Then then we update our local state with whatever they return us. Right. Yeah. So that's the end of the exercise 8. Yeah. So a quick recap for uh everything we have done today. So we build a skeleton for our app. Then ZhengHao teach you guys like how to use state to add interactivity to the app. And we have learned how to divide our web app into small and reusable components. So initially, our file is just like a huge chunk of everything in between. It's like everything is on the same file, but slowly, we have decoupled the components, just by breaking down, dividing in small components to header, task component, task input, task manager, for example. Uh, then, then we learn some key concepts like lifting out the states, different real code such as use state, use effect, props, or where you pass something down from parents to children, and conditional rendering and some styling. And, and, and finally, you have learned how to implement strategy on your app by dealing with local states. So we still have an upcoming workshop next week. I think it's the same time, like next Saturday, 10 to 12 p.m. We'll be doing stuff more advanced. So we'll be starting our web app with some UI library. So I haven't decided which UI library I should use yet. Most likely it's going to be like MUI or Chakra UI. So if you have any comments, if you want to see like any UI library that you want to use, or what that you want me to use, you can leave a comment here or something. And also we'll be browsing documentation for the multi libraries. And finally, so we'll persist our data with Superbase database. And also we add some authentication to our app. So the multi-user example is so different users should see different to-do lists, right? They are not sharing the same to-do list. So that's how why we need to have authentication. So the user only do CRUD to his account. So it doesn't mix with another users. And finally, deployment. So So I think the next week one is will be a lot more fast paced. I won't be like teaching again. We won't be teaching again what you guys already have learned in this workshop. Yeah. So I think for now there's a plan to cover all these. I think it's likely to all run as well. And also we have shared some resources here. Uh a quick start guide, which I think give you a very comprehensive um of a real example. Uh so I think example is still in JavaScript, but since you have followed everything today, you should be able to completely code in TypeScript as well. And also just now I talk about use effect. So this article is a really good read of what it is telling you that you don't always need use effect. I mean most of the time, like I would say 90% of the time you don't need use effect. And it actually like I think and also like 90% of your bugs is actually come from inappropriate use of use effect. So I think this article is really good. Tell you like um when should you when should you only use effect, and a couple more rare hooks. So for this workshop, we only cover like use state and use effect. And actually there's like couple more that's I think is pretty important. So I think next week likely going to cover like use callback, use memo, and probably use context if I have some time. But I highly encourage you to actually go and read um all the React basic hooks. So it just give you more idea how you should call your app at like on the higher level. And also, please to read our wiki, uh, if you haven't already. So we have comprehensive guide on JavaScript and TypeScript, and we do have some notes here for React. Uh, I think we'll be slowly like updating this wiki more frequently. Yeah. So that's it. Does anyone have any questions? I think I'll just stop recording now. Like I think like if you have questions, you can stay. But I'll just stop the recording now.